Welcome to our next session, which is Infrastructure and Other Enabling Factors. Our next speaker, Rex J. Alexander, President of 5 Alpha. Rex is doing research and consulting on advanced air mobility, mainly in the United States. Rex, the virtual stage is yours.
Good morning.
Yeah, hi, Rex. Since we don't have your presentation, would you like to share your screen, or you can also send us your presentation? We can play from our end. Okay, perfect.
Okay.
Thank you, Rex. Now the stage is yours.
Well, thank you so much for the opportunity to speak today. I greatly appreciate it. Good morning from the East Coast in the United States. I'm speaking today on behalf of the Vertical Flight Society about advanced air mobility. My specialty in this arena has been infrastructure. And in the infrastructure world, the Vertical Flight Society has brought me in to be the advisor for that. So there's a lot that we've been doing over the last 2 years in this space. I'm just wanted to share some of the things that we are involved in and engaged in, and give you a very high level of the things that we're looking at overall, not here just in the US, but at a global matter. So if there's any additional information you're looking for, I'd definitely point you to the Vertical Flight Society's website, vtol.org. There's a lot of information there. There's additional information for members that do become members. We have a tremendous library of white papers. We're starting to populate that with infrastructure white papers. So in this space, one of the things that we look at are the standards for the infrastructure. And these are for the primary organizations that we are partnering with and working with in this space and communicating and collaborating with to advance infrastructure. I am engaged with all 4 of these in one way, shape, or the other. ASTM, if you're not familiar with them, has a ASTM F-38 unmanned system that has been in the last 3 years working on infrastructure standards, and hope to have something published as a standard from them here in the very near future. The Federal Aviation Administration is just really starting to gear up in this space. They have a contract that just started about a month ago, and it's probably going to be about a 3-year process. ICAO is just now really starting to get involved. It's probably a little bit behind the Federal Aviation Administration right now. YAS is doing a lot of great things in this space, and we hope to see some published information from them as well soon. So in infrastructure, some of the considerations that we look at that we're very in tune to are aircraft performance being one very specific piece, given that there's so many different types and modified aircraft. Things that drive the infrastructure and the infrastructure design, definitely aircraft performance, the dimensions of the aircraft itself, the landing gear configuration, how does the aircraft move on the ground? Is it going to be self-propelled? Is it going to move on its own power? Is it going to have multiple lifting system configurations? Are those lifting systems going to be articulated, and will they change orientation during transition? Safety redundancy is a big issue. Weather, winds, turbulence, and lastly, noise are all considerations. In the building code world, this is separate from what we look at from the aviation side, but the building code, the fire code, electrical code, plumbing code. So ICC is the International Code Council, National Fire Protection Association, or NFPA, are all working on figuring out what we need to do as far as the code side. So fire code's a very big piece in this, and it will play a major role in how we design our infrastructure. Some of the considerations that we work with in the infrastructure is, what's the aircraft weight? We not only have to design for the static load, but we also have to design for the dynamic impact load. If it's all electric, we have to then incorporate all things for the electrical code to include charging systems. If it's hybrid electric, then we have to take into account fuel and electric. We do very well with the fuel right now, but we still have a lot to do in the space of electric. Hydrogen fuel cells, the NFPA, National Fire Protection Association, has a tremendous amount of information on hydrogen fuel cells, but we have yet to leverage any of that information towards aviation. Charging systems, we look at the charging systems and the makeup of those. If you have one charging system at say 500 kilowatts, and then all of a sudden you have 10 at 500 each, now you're at 5 megawatts. That's a significant amount of power usage in a small space that we have to account for. If you're doing battery exchanges, we have to figure out how much battery material can we store on site. What are the fire code standards for that? Electrical storage systems, the ESS, for downtime of the electrical grid for capacity. We do have a significant amount of information on that, but putting something like that on an elevated structure has yet to be done in this space. Some aircraft are actually looking at using chemical cooling systems for battery recharging. Then there's the electromagnetic impact. What impact does all that electricity have on the aircraft navigational system? What does all that electromagnetic energy have on a human being? Aircraft performance is one of the big things that we're talking about with NASA and the FAA right now. Flight transition profile is one that we're paying very close attention to. Is what's the aircraft's transition look like from cruise flight to hover flight? What type of space do they need? What airspeed are they arriving at, decelerating to? Or what's the angle of approach that they can accomplish? Are the aircraft capable of out-of-ground effect power, similar to a helicopter, or do they need more room? What's the crosswind controllability component of the airframe? What's the downwash in approach and departure mode, but also what's the rotor wash or the velocity of the jet blast coming off the aircraft if it's moving on its own power on the ground? Some of the aerodynamic deficiencies that we deal with in helicopters that we're paying very close attention to are things like settling with power, vortex ring state, duck stall is something that we see in larger aircraft. When we talk about vortex ring state, that's a known quantity, but we've also seen that in drone operations and quadcopters, and also with the tilt rotors have all experienced vortex ring state, which have led to accidents. So we have to pay very close attention to that when we design and build the infrastructure. Turbulence in urban air mobility infrastructure. So in the urban canyons, this is a wind tunnel test that I was involved in that shows the vortices that you deal with on any given day based on the architecture and the air gap. So we pay very close attention to this because it really has a huge impact on performance of the airframe, the controllability, both the workload on the pilot or the workload on an autonomous system, and then also the ride quality on the person as a passenger. Weather forecasting, real-time reporting, this is going to be a challenge. While we have really good weather at airports, most airports are not in urban environments. So getting good quality real-time weather information from an infrastructure standpoint is going to be huge. Infrastructure workshops that the Vertical Flight Society has put on so far, we've had 3. We're putting on another one in March of 2021. You can find that information at vtol.org/infrastructure. More than welcome to participate in that and join in that. The other 3 infrastructure workshops that we've done, a lot of that information is on our YouTube channel or also on our VFS website and is accessible for our members. Some of the people that we're working with right now in infrastructure and collaborating with, ASTM was one we talked about, definitely very closely tied with NASA in this space right now, and also working now with Helicopter Association International. NFPA, I serve as the Vertical Flight Society representative to NFPA. National Center of Atmospheric Research, we're talking to them on the weather piece on a regular basis, and Gamma, very, very active with Gamma. So that's just a small sampling of the people that we do work with in this space. As far as our membership goes, we have over 6,000 members in multiple OEMs and organizations and universities. So that's real quick in a nutshell what we're doing in the vertical flight infrastructure space. If you have any interest in joining the Vertical Flight Society, you can do so at the vtol.org. If you have any questions specifically for me, there's my email address. We also have a pretty good presence on social media. We have a really robust YouTube channel with lots of great information. We also have a Twitter account, Facebook, and a LinkedIn account. So I would recommend that you get involved. There's a lot of good information that you can learn in this space. So real quick, that's my presentation, and we got time for a couple quick questions. I'm more than happy to entertain.
Thank you, Rex. And yeah, good to see you first. Haven't seen you for a year. Normally we see us much more often around the world. And thank you for getting up that early from in United States for us.
Oh, no worries, no worries.
This overview, because I think it also shows, and perhaps people will wonder why we suddenly have somebody also talking about helicopters, but I think, and you will hear tomorrow, that we will have short takeoff aircraft in the section also with VTOL, because they are working in some spaces together. And I think air taxi as well, there are some with wings, some without wings, some with vertical takeoff, some without, especially when you're talking about enabling takeoff space on an airfield. Then things you talk we will definitely consider. Yeah, now we have two more speakers in this session, and then after this session we will continue with an open discussion, not with the breakout rooms, because we had still some people who have difficulties but would like to ask questions. So I would like to ask all of you to stay online if possible. Rex, I hope you can survive with the coffee. And I will then, all people who want to ask a question, we will still mute everybody who want to ask a question, puts on his camera, then we see that he wants to ask a question, we can unmute him, and then that's how we try to avoid Babylonic noise. So now, next presenter, Johannes Garbino-Anton from BBAA, and he is giving us an overview about a very interesting infrastructure project, or not infrastructure. Yeah, it's kind of infrastructure for the aviation, which shall enable manufacturers to get their electric aircraft products certified and in the air. The stage is yours. Thank you.
Yes, Willy, thank you very much. I hope you can see and hear me by now. And yes. If that's the case, okay, thank you. Then I will give a quick presentation about our ongoing development for the technology center, which we call CEFA. I was asked to give a quick update in the infrastructure and enabler session, which we see this and we plan this actually as an enabler for the whole region. And I later come back to this. I think this will also be necessary in a lot of different other regions and can be a good multiplier. So here you see a first draft of what we think of, and I will now go a little bit into the details. First, a quick background who we are. We are the Berlin-Brandenburg Aerospace Alliance, which is the local aerospace cluster here in the capital region in Berlin and Brandenburg. And here on the page you see a part of our members, especially the ones which were in the IBEFA project, which was aimed in the last 4 years at developing the area as one of the key regions for hybrid electric aviation and low emission aviation propulsion in general. A subset of these partners are also with us in this CEFA Technology Center project, and there I will give you a few more information right now. Here you see a rendering of the surrounding and the industrial park at the Schönhagen Regional Airport, which is just south of Berlin. Actually, in the center, you see the rendering of the technology center as we plan it right now. And left of it, you see further development space for hangars, roughly 2,000 square meters, where we already have interest of partners to settle there. The rest of the buildings, which are also rendered in this view, are actually already existing hangars and also an industry park with aerospace companies, Aquila, RS Aero, Stemme, and a lot of other aerospace businesses here at the regional airport. A few words towards the profile, how we see it and how it developed in the last 3 years. We see a big need for infrastructure for applied aerospace research, especially for hybrid electric fixed wing aircraft. That's our initial focus, up to the infamous the 19-seater. With a very high focus on integration and testing, with topics like also noise and very certification-driven problems like EMI and so on. But always with a high product focus, which is needed by now. We have seen a lot of development projects for prototypes, proof of concepts, and as you saw in the last 2 days, and I guess also we'll see tomorrow, there is now the shift happening towards productization, and that needs more serious testing and infrastructure. One of our other projects that I also will quickly go into, which also has synergies to this, is we are planning for hydrogen infrastructure and power to liquid, power to liquid based fuels, so to say. We have a lot of thought put into the media, like hydrogen cooling and so on, which has to go into this building, which is part of the whole backbone of the building I will show you in a minute. And altogether, we see that the whole space is very multidisciplinary driven. I mean, there are a lot more disciplines than in the classical aerospace coming together, and they need a new work environment to work closely together. And then I will not go further into detail in those. There will also be an incubator for small companies and the supply chain, but also a design thinking lab that we plan with the Hasso-Plattner Institute and their design thinking school. This is now not the worldwide, but only the German vision that we mainly focus right now on, or the Middle European one, where you see other centers. Actually, it's a little bit offset, sorry about that. So you can see there are a lot of epicenters where we see development happening, where you already heard about Aachen and also from Stuttgart and so on. And so we see different capabilities at different places, but also a lot of commonalities and a common need to test. And only a few ones have access to airfields, actually Aachen being one of them, and they even prolonged their runway, which is really great to see. And we also think there will be more need to get testing right at the airfields with the flying test beds, but also products. And as I said here, our focus is mainly in the integration testing towards certification and productization. A few datas, we are right now in the detailed design, you would say, 4,500 square meters, roughly 25 million overall investment. We have a great funding program for infrastructure here in Brandenburg, where we see roughly 80, 90, now due to Corona, up to 95% funding. And we are already in the grant application, it should say, progress. We submitted it earlier this year and have several private investors we very closely talk to, where we hope to can move forward early next year. 4 companies already located or relocated here just due to the process. And that's what also in the last years, what we saw, one of the companies need partners that they can talk to and work together with, and they need a place to do their business. And we learned in the process that this infrastructure really can be an enabling factor. Here in the small picture, you see it has a few in the background, normal office spaces and electronics laboratories, and then the connecting building frame is this glass building where all the co-working can happen, and presentation, and a new work environment basically. And then 2 hangar sites, the left one mainly for integration of the full aircraft, the right one for Ironbird and subsystem testing, but always with a integration aspect happening right after. And on the very left, you see something that is quite important from our learnings, that you have an outside area where you can fix the aircraft down and do full power runs, long endurance testing, noise testing, but also with the media infrastructure right at the test site. So you can run the hydrogen supply lines directly to the site, the cooling, external liquid cooling, and also power to liquid, and up to 4 megawatt electric power is what we plan for as a source, but also as a sink. Yeah, this is another project that synergizes with this. It's a network Kiefer, which is, I will not go into detail, but it's for regional airports that, for sustainable aviation, so electric charging infrastructure, hydrogen, and especially power to liquid. Some of our partners there. The idea being that if you produce the power to liquid and hydrogen right at site with green energy, then you can spare all the transport and have a lot of interesting aspects that also combine with, in this case, with our technology center. Here you see the bigger picture at the airfield, where we also develop in one of our projects, which is called ETL, the photovoltaic field here in blue, right at the departure end of the runway, which is a challenge in itself, but solvable. And we look at 9.5 megawatt peak electric power from there, which translates into roughly 450 kilogram of hydrogen, if you consider it on a rough yearly production basis per day in that case. And there you see the development area left to right. The power to liquid station will go somewhere in the middle, and then our technology center on the right far side. Another project that is also integrating to this is we are also working closely together with the airfield of Strausberg, which you see in the upper right corner. And between the two fields, we will have charging infrastructure, hydrogen infrastructure, and potentially also a power to liquid infrastructure, and are talking to the authorities, having a dedicated test area in between those two regional airfields, which are quite interesting then for testing. And as you can see, as a small gimmick, Tesla is right at the corner. We used to call it the lower left corner of the controlled airspace. Now everyone just refers to it as Grünheide in this case. Yeah, that's my few minutes. If you want to reach out to us, we are happy for any contact, any interest. And yeah, this is how you can find us. So thank you for your attention.
Thank you, Johannes, and very interesting. I know you would have much more to tell, like most of our speakers, and I would like to listen more, but we have limited time due to, you know, we have to do it in China and here as well, and we don't want that the people don't get to sleep anymore. We have one more speaker for today, and then we will have a Q&A session for everybody of today, because we had a request that, you know, the breakout rooms sometimes are difficult for the people to join. So now the next slides are already on. So Vincenz, if you could come back, or not, yeah, because you've been up on the stage already before. If you could come back up and give your presentation here, which is very interesting and a little bit similar. And there you see really the structure of the Federal Republic of Germany. We have something which is developing near Berlin, and we have something now around Stuttgart in the Baden-Württemberg area, where the heart of the car industry. So yeah, I'm interested to hear what you're planning there.
Hi, thank you for your introduction. Can everybody hear me?
Yes, we hear you fine.
All right, great. Thank you. I am Vincenz Frenzel, a research assistant at the University of Stuttgart. And in this presentation, I'll give you an overview over a newly established aeronautical research area in Baden-Württemberg. This test field, eFlight BW, consists of test facilities at 2 different airports in southern Germany. And this all will be completed by summer 2021, but some test operations have already started. The project is together with several industry partners in the region to establish those test sites, and the entire project was funded by the State Ministry of Economics. And the University of Stuttgart and me in person leads the project, and key development partners are Volocopter and Thales Germany. The facility is operated by a newly found association called Area BW, and I will give more insight into this structure in the next slides. So the main objective of this ongoing project is to develop test fields in southern Germany. And the main goal of these research sites is testing and demonstration of entire systems under realistic conditions. Our focus lies on electric, autonomous, energy efficient, and urban flight. One major aspect is integrating these new technologies and use cases into the public airspace. However, the test field is open to any interested company or any interested person looking for a flight test facility. With these aspects in mind and these goals, the facility enables quick turnaround times between ideas and according flight trials and demonstrations. The test facility supports its users regarding flight permissions, operating procedures at the airfield, insurance requirements, and especially a wide choice of ground infrastructure. Hold on. There we go. So one of these test sites is located in the west of our state, close to the French border, at the airport of Lahr in the Black Forest. This very spacious test field with a 3-kilometer asphalt runway and an airport area of over 6 square kilometers allows very big tests on the airfield parameters. The field itself lies in an urban environment with a highway and a high-speed railroad line. So this is suitable to also test multimodal traffic concepts and transport to cities eventually. An airplane hangar and office spaces are available to the users, and these facilities are also equipped with an extensive workshop with lots of equipment and an air taxi ground station. And there are various other tools and aids for testing UAM vehicles. The other test site for autonomous flight, so this was the test field for urban flight, and the test field for autonomous flight is located about 120 kilometers east at the airfield in Mengen. It features an asphalt runway of 1.5 kilometers and an additional grass runway. For flight demonstrations, permission is already available for vehicles up to 150 kilograms and allows flights up to 300 meters above ground level and even outside line of sight. And therefore, a segregated airspace a segregated airspace is close to the airport, and that shall be integrated to the allowed flight test area in the future. There also an aircraft hangar is available, and currently this is rented, but a new construction is currently planned and will be available by the end of next year. It includes office spaces and a workshop with plenty of equipment and storage. For the experiments, various ground equipment is available to the users. So, for example, it includes a high-precision differential GPS system, a secured and robust beyond visual line of sight communication link, and an integrated air picture using hook-on devices, FLAN transponders, ADS-B transponders, and radar data. And on top of all of this, we actually will install an active drone radar to develop to detect other drones in the airspace. The current permission that we have for this airport allows drones up to allows operation of drones up to 150 kilograms, and they can be propelled either with electrical power or a combustor. And this permission for now is valid until 2021, and we are hoping to extend it after next year. It allows to operate drones inside the airport perimeters, which are down here, and also outside in the north in a newly established BVLOS test area of around 2 square kilometers. And for using this BVLOS area, a fast transit is required over a primary road and a train track, and that is obviously permitted. For performing flight tests outside line of sight, so in this BVLOS area, specific SORA GER must be documented, but it is not required that this is approved separately. And potentially in the future, the two test sites can be connected with a BVLOS corridor between the two airports as soon as the regulations allow this. Additional ideas for the test sites are development of a PV electric system, photovoltaic system, and also a hydrogen generation inside our newly constructed aircraft hangar. And then at last, I would like to give you an overview over this operation association. The operation of the test field, or the test fields are operated by this association called Area BW. The membership for research or experiments is possible very easily and can be requested temporarily. It allows usage of the ground infrastructure, the operation procedures, and the takeoff permissions. Assistance for the drone insurance can also be obtained. If users perform intensive testing campaigns, additional test fees can be expected, but they are dependent on the individual usage and the requirements. And surely the test operations are organized taking measures to retain confidentiality and sensitivity. Overall, any kind of operation can be performed at our test locations, and the users are free to choose their preferred test site, either the test site of autonomous flight in Lahr, or the test site of urban flight in Lahr, or autonomous flight in Mengen. The current operations include manned and unmanned flight, small drones and heavier drones, air taxis, rotary wings, fixed wings, transition vehicles, and even lighter than air vehicles, and potentially in the future even optionally piloted vehicles. The aircraft propulsion can be either electrical or combustion engine or even jet motors. So thank you very much for your attention, and if you have any questions, feel free to ask now or contact me in person. Thank you.
Thank you very much for this presentation. I know I pushed you to be quick, and thank you for being very quick, and which leaves us time for some questions. Before I ask the first question, I just give again the explanation how we would do so. If you could unshare your screen, and all the other speakers from today would get back on the screen, and then we can start. And if somebody of you wants to ask a question, then you could, for like everybody's unmuted right now, but you could raising your hand, you just show your screen, then we see that you want to speak, and we will give you the mic like in a real presentation, and then you can ask the question to yourself. For the moment, we had one question. You're gonna ask it? Okay, yeah, we're gonna ask this one question, so I'm silent now.
We received a question for both Arrow. The question is the electric motor used by both Arrow certified or certifiable? Is there a pathway for the certification for electric motor for 4C electric airplane? That is the question.
This was to Otto Grünwald. I hope he is still in. Doesn't seem to be so. So we will forward this question. And one thing for you, for all the visitors of the site, and also for you speakers to know, this is really sometimes only a rush through a large space where you sometimes with several 50, 60, 100 or more people working on. So we will do follow-up calls of this, where we'll do small panels, just one panel, record the panel, and then put on our channel, which we do on a regular base already, which are the eFlight Garden Talks. And so if you have any questions, we will join this question, then ask them later, because sure, here we are limited. For the moment, I have a question from my side, which would be for Johannes. We heard about, and also Vincenz, because we heard about this, what is happening in Germany in several areas, and I think it's the same in other countries, and I know it's the same, like for example in France and in other areas. Is there any cooperation, any coordination in Europe for this kind of fields? Because sure, it would be much better if they are more complementary than competitive. So if everybody makes now an eVTOL test center, let's say 5 pieces in Germany, this is probably more than we have manufacturers, and this will then be difficult. So are there any government organizations or private initiatives who try to coordinate this, as you know?
Yeah, that's an interesting question. So no, there's not. I mean, the Ministry for Transport could be one. Yeah. Right now we are coordinating this with the German Aerospace Center DLR, and there especially with Mr. Andreas Klöckner.
You're a little bit if you can speak a little bit louder, it's a little bit weak, your voice.
Okay. I hope you can hear me now.
That's better.
Okay, yeah, so Mr. Andreas Klöckner, who is the coordinator at the German Aerospace Center for Electric Flight, he's also coordinating right now the development of the different aerospace research centers, especially for hybrid electric arena. And we are in close contact with him and also with several others of the centers, since we also see that we have to be careful that there's no useless doubling of infrastructure. But on the other hand, we also saw that it needs even more. So if a few more regions want also to join us, we are happy to share our learnings and to recreate what we have already worked on.
Okay, Vincenz, do you have a comment on this?
Right. Well, I have the same. I have the same impression. There's not a lot of coordination going on currently, but I think this is related to the fact that it is important that the test fields are located close to the companies who would like to test. So actually, I do not think that the different test sites in Germany compete against each other or are competitors, but I think that a lot of test sites are essential so that every company has a close-by airport where they can have a quick turnaround time. From the conversations we had with industry partners, this is the key aspect to choosing their test site. It is not what is available there, but it is what is the costs of transit to this test site. So I think we will need a lot of test sites, but sure, the coordination could be a little bit extended at least.
Yes, thanks for this answer. Question to Rex, because you're in the infrastructure development, I know you're closely connected to Gamma. Is there anybody who's trying, because I think in states I know it's the same, there are also several states which want to be the first, which are supporting it more. Is there a coordination of the Ministry of Transport or of any or NASA for this kind of facilities?
Definitely working very closely with folks at NASA. Their group under NARI, N-A-R-I, has been engaged in doing online working groups for a couple months now. And collaborating between NASA and then Gamma and the Vertical Flight Society with our workshops. And then the other group that's out there is called CAMI, C-A-M-I, which is a community aviation mobility and infrastructure. So all of us are working together in that space and really reaching out here in the US specifically right now to each individual state and trying to make sure that all the departments of transportation are on board, because when we look at the infrastructure, it's like we're going to see something as a viable business product within the next couple of years, and we have to get ahead of that. Policy is lagging significantly behind technology, and we're desperately trying to catch up. So in that space, we're working very closely with all of those agencies and trying to bring all the different players to the same table so that we can move forward. It's a heavy lift, but we're making good progress.
So thank you. Good to hear that this is happening in the United States. And so perhaps for us here in Europe, what we should do is perhaps to get more perhaps also the European Commissioner of Transport, who we are spending, the EU is spending quite a lot of money on research, but perhaps if they could also do some kind of coordination, which should not say, no, it should be here in Germany and not somewhere else, but if there is more coordination, I think it could be more effective and also could accelerate all the developments, because I know from smaller manufacturers which just had quite a lot of difficulties of getting test capabilities at least 1 or 2 years ago. One request now, because I scrolled through the list of our presenters and of our visitors which are still online. So if those who have been presenters, and if they could switch their camera on again, so people would see they're still there, and maybe they have some interesting question which is also interesting for for the other people, because otherwise you're not able to share the thoughts here. I have a question or a comment actually on this, which is leading to tomorrow, because like Rex was speaking on especially on the vertical lift area, where you have, let's say, VTOLs and helicopters, which are kind of VTOLs because they take off vertically. They are the first VTOLs we had, and so to see that these things are connected. It is not that one is doing the conventional aircraft and the other one is doing just the eVTOLs, because there will be no eVTOL without an electric powertrain. And so if the development of electric and certification of electric powertrain can be supported, this will support both sides equally. And so for this, interesting, I think I mentioned it before, that just today the big news came out that Uber Elevate, who was the pushing factor of the eVTOL society over the last, I would say 4 or 5 years, since eVTOL really popped up in the eyes of the public, that this company now has been purchased by Joby, who made the news in the beginning of this year when they got a big investment of Toyota. And so tomorrow we have somebody from Joby early at the podium, Greg Bowles, who was there already speaking yesterday. And he told me last week when we prepared this call that he cannot say any comment on the Joby deal, but as it's out now, we'll ask some more questions and perhaps we get some more interesting news. So stay tuned for tomorrow. And I have a question at this point on Johannes, because you also work, because I think Philip is not anymore, he was in the call earlier, because is your activity, because you also worked on the APUS project, is your activity in Berlin-Brandenburg also connected now directly with APUS? Will APUS be located, for example, at this new facility, or will they stay where they are? Can you unmute? Johannes? Yeah, it's on the way. Unmuting. No. Yeah, now you're unmuted.
Okay, now I'm back online. Yeah, thanks. Yeah, so Arcus is definitely one of our key partners here in the area. They are making great progress in quite some projects, and they also have activities that they think might make sense in such a technology center. I don't think they would relocate. I think they also have by themselves built quite some good infrastructure. But there's definitely will be for almost any project a point where you need to do more detailed testing on electromagnetic interference and so on, or noise testing, and then you have to move. And then the question becomes, if you have already a flying demonstrator, it's easier if you can move it by air to an airfield where you have a test center right at the airfield. And if you want to move into flight testing, once you have to trailer it, and then afterwards you can fly it if the technology center is at an airfield.
Interesting, and this leads me to a comment and a question there, which is interesting, because yesterday or last week preparing this, we had some discussions, because like we have this airfield now in Mengen, which should be perhaps also be a place where you can fuel with hydrogen in the future and with electricity fairly soon. And there is already at the Stuttgart airfield a possibility to refuel with hydrogen, which is basically for the ground traffic. I think the only aircraft with hydrogen which was taking off, you were in, Johannes, when you were doing the maiden or official maiden flight of the High 4. But basically, there is an infrastructure growing for hydrogen also for airfields. And we heard that the Aero Friedrichshafen, the largest fair for general aviation, they are now in discussion first with the airport, first getting an electric station, but as one of the largest companies there in town, ZF Technik, now also announced that they will work on the hydrogen sector with the car industry. It's very much likely to expect that maybe they also will get something there. And then we slowly get some kind of, at least first some triangles of several airfields. And then later, if we get some connection, would be great that in 2-3 years, we perhaps could have a fly-in at Aero, where you can fly in with an electric aircraft, although it's limited. But as you have several aircraft on the way where you can refuel with electricity or even hydrogen later, then this would be, I think, a very nice thing. And we already are in the planning for the eFlight Expo panels, which we will have at Friedrichshafen. And we definitely like electric infrastructure and infrastructure for VTOLs and infrastructure for hydrogen will be key subjects, because there is now an interest in the policy to support this. And this, I think, is definitely something which is needed, because it's the egg and hen problem. If there is no infrastructure, nobody will buy electric planes. And if there will be no electric planes, nobody is going to build an infrastructure for it. Having this said, Matthias, you're getting along with your aviation project for more than 25, probably 30 years, and you've seen a lot of changes. I know him from, we're doing hang gliding. It's a sport which a lot of people don't know anymore now, and over paragliders and to ultralight, now to certified aircraft, now to electric aircraft. So do you see, like from the knowledge you have, there is an area in the world where it's growing faster, this kind of infrastructure? Like, or is Germany changing in the lead already?
It's changing. It's continuously changing. So I would say that in the very beginning, America was leading. I think when I see the development, what's going on now in Europe, also with the EASA, with their Part 21 Lite, I think that will be a big pusher for new development, new technology. And when I listened yesterday what the CAC is doing, that will be again a big pusher for China. Yeah? So I think it's a completely changing situation. And with that, I think wherever you are in a good place. I mean, if you are in the US, you are in a good place. If you are in Europe, you are in a good place. And if you are in China, you're in a good place. Germany, it's not so easy. So when you see how skeptical there are on some technical developments in aviation, I just mean it's a very, very simple thing. If you look at the German ultralights with the autopilot, for example, and then if you deal with that for 10 years, that's not an example how you implement new technologies or require even so.
But on the other hand, if you see, for example, the project where the high four and the projects with Josef Kallo explained yesterday, and he's working on, and if you heard about several.
But that's EASA. That's EASA. You know, that's no. I mean, that's German guys.
You mean in the lower sector where you have the but on the other hand,
no, it's a general thing. I think it's not when you say it's Germany, no, I don't think it's Germany. I think it's at the moment it's driven by Germans who are driving that. And when they have to work with in the most of the areas, so like we do, we have to work with EASA. And EASA is definitely a positive thing. And when you look in the different countries in Europe, and you say, where would you select to in reference to place an aviation company? Okay, there will be, I think, pretty sure a certain ranking.
Okay. Interesting question on this to Rex, if you could unmute. I think he's muted, because I heard this year in spring or before Corona started, we had the meeting in San Jose where it was said, or the Vertical Flight Society said that they also now implemented this stall aircraft into their focus a bit, because there are several projects where people say, okay, due to the energy needed and so on. So have you, as you work in infrastructure, have you also already worked for kind of stall projects now where the people say, yes, this is a project, we think this is a kind of aircraft we need? And I think we heard this before from the ESAT team. They are also looking into short takeoff and landing for having as many possibilities in the country to land.
No, it's a good point, because we have seen that. We have, I think at last count, over 350 different concepts floating around as to what type of aircraft these will be. And some are stall aircraft. So we've had that conversation now with the Federal Aviation Administration here in the US, and decided that we need to develop to that, not only for the eVTOL vertical takeoff and landing, but also stall. Now, in their mindset right now, we're not sure if that's going to be part of the standards for eVTOL or will be separate, but there will be some type of standard that will need to be looked at. In talking to several of the different countries that are trying to embrace this new advanced air mobility, one of the challenges that I've seen is they don't want to spend a tremendous amount of money on creating multiple types of infrastructure. They want to create one infrastructure that services all different types of modes of transportation. So when looking at that, if you have a we'll say vertiport that services, say it services helicopters, say it services eVTOL, it also services stall, and it also services large UAS drone operations. Now my investment dollars are lower because I have one set of infrastructure versus 5 different types of infrastructure. So that I see that conversation going on right now very heavily in Canada and a couple other countries. So stall is one that we're paying very close attention to and trying to adjust for, because it is a different animal. You have different geometry that you have to account for, but at the same time, it does provide unique opportunities and you don't see in some of the eVTOL models. So good question. Thank you.
Question on this to Johannes and to Vincenz, but you mentioned that you will have VTOL is also in your planning, and with Volocopter in LAR you already have it, but is in the Berlin project, do you also plan having the VTOL integrated in your concept for testing, for flying? Or are there other centers in the Berlin area which you are aware of?
Yeah, it is not our main focus. One of the reasons being that we are in Germany, we just talked about, and it's easier to take the old school aerospace established also research and rest of the companies in the fixed wing world, hybrid electric first, or in the discussions, and kind of bracketing out eVTOL, since especially I guess this German engineering thinking, old school, it's easier to have the conversation starting there. And then I guess in the future there's no prohibiting factor that the same technology bricks with more distribution and more redundancy also go into eVTOL, and also the same testing infrastructure. I mean, especially for eVTOL testing, it might make sense to keep even more distance to a clouded or congested airspace, and also populated areas like especially Berlin. But other than that, I guess the research that has to go into it is quite similar.
Okay. Anybody have another question? I just have to look on so that I don't overlook them at the moment. No, I don't see any concrete questions at this point. So I would have a question on all of you, as I know you work on electric projects. Do you have, will battery technology advance as fast so that we will really have a lot of electric flying before we will have to change to either perhaps hybrid or to fuel cell, or will battery flying only be a very short period and then it will go to some other fueling factor? Because I think it will be very difficult to build up a fully electric charging infrastructure and at the same time try to build up a hydrogen infrastructure, for example, because this will be very costly, and the society will very much think about where they gonna invest the money. So first, I don't know. I think perhaps I can ask Rex for United States, because we talked recently on, like let's say last year, we had the big discussion on how much the electric infrastructure would have to be modified to be able to really service large eVTOL centers in the center cities without the light goes out when all the landed eVTOLs have to charge at one time. And so have there been any thoughts on hydrogen in United States recently as well?
Definitely having those discussions. We had a conference call last week with our friends at the Federal Aviation Administration, and that has all of a sudden really showed up on their radar. So what does hydrogen look like, and what are the criteria that needs to be met? As I said, the National Fire Protection Association actually has a significant amount of information on hydrogen. It's just not pointed directly towards aviation.
Yeah.
So it wouldn't be too hard to leverage that information and bring it into the aviation fold with some work in that space. On the electrical side, you brought up a good point. Is in the U.S., one of the challenges that I think the OEMs have is with the required reserve. So as a helicopter, you have to have 20 minutes of fuel on board after you land. So that's one of the things that I think the OEMs are bumping up against is, well, if I have to have 20 minutes of power still on board when I land, well, that means then my range is significantly reduced. So until they find a way to deal with that challenge that's acceptable, I see hybrid, and in this case, the hydrogen being maybe more appealing from a business standpoint.
So, Vincenz, you as somebody you're working on the airfield there, it's research, yes. So research, hydrogen is always, or has always kind of been focused. And I know some years ago we had in Oshkosh one of the first electric aircraft meeting. And at that time, somebody asked a question to the leading battery researcher, and he said, yeah, hydrogen is the energy of the future and will ever be, which at least up to now was a little bit like it was, because I remember in the beginning 80s, there was big stories and I thought I would drive a hydrogen car probably in the beginning of the 90s. By now, it's another 20 years later, I was flying an electric aircraft, but fuel cell is still not really available. Johannes, you have flown such an aircraft, like a fuel cell aircraft, one of the very few persons probably. Is there any special things in handling or any special safety requirements which you had there that you don't have in a conventional aircraft?
Yeah, yes and no. I mean, on the prototype, yes, definitely. But if you think of it in a few years down the road, it will be like a fuel cell car. So those will be handled like any other gases-driven car. The infrastructure side is true. I guess, especially if you look at privately owned aircraft, you would like to have infrastructure anywhere you go, and that will not happen in the beginning. But especially small commuter aircraft, which we also believe in 10 to 20 seats, will be more regular on direct decentralized routes. If you look at Germany or Middle Europe, you only need a couple of dozen airfields where you put hydrogen refueling, and then you already have a network that can serve 70–80% of the decentralized flights. In the very beginning, you think of the infrastructure as almost being part of the airport and the aircraft investment. So you need 2 infrastructure sites and then you have a route. And once that gets more, then it also makes more for the smaller private aircraft. But I guess that's the main differentiating factor between going battery electric and hydrogen electric in the beginning. Okay.
Vincenz, you have been like, your project is supported by the Baden-Württembergish Ministry of Economy, and so your discussions there, in the politics you talked with, it's more going to electric or more going hydrogen, or what is the focus at the moment?
Well, that is a tough question. I don't think currently it goes into any direction, to be honest. I think well, the state ministry that funds our test field is actually, well, in our state we have a big car manufacturing industry. So this is actually the same ministry that funds projects for the car industry as well as our test field now. And there the tendencies also go from electric maybe towards hydrogen, because it does have advantages. I don't think it can be currently said which of the 2 technologies are more advantageous, and I think for a while these 2 technologies will compete and will be used alongside, both for car propulsion and also aircraft propulsion. And a good way to go forward, as the as the technology is still developing, is actually hybrid propulsion. So for example, on the eGenius of the University of Stuttgart, we have recently installed a range extender. This is was purely an electric propelled aircraft, and we are also still working on the e-Commuters with the solar, which is solar powered. So these are two research aircraft that are currently still developed and used as research aircraft for electric propulsion, but we also have tendencies to go towards hydrogen propulsion and the hybrid concept. So I don't think you can pick either way currently. It will take a while until one technology will outperform the other.
Okay, thank you. I don't receive any questions. We still have about nearly 100 people in the call and quite a lot of people joining the live talks not the live talks, the live streaming in YouTube. But I also think we reached our time, and it would be nearly the first time that I finish in time. So if anybody of you has a question to each other, yes. If not, then I would, so I first shouldn't, so any question from any side here? Rex, I see you unmute your phone. No.
No, I had no questions. Just wanted to make sure I said thank you. Okay,
great. Now then I would say, yes, two things. First, if you have time, please join tomorrow when we talk about the eVTOL segment of the electric aviation at the eFlight Forum. Second, if you have any further questions to any of the people, we leave it a little bit on the call so that you over the chat still can exchange your data, and we will also save all the data. And if there are some unanswered questions, just contact us. In worst case, send it to my email, willy@flying-pages.com. And then I'll definitely, if we don't see you tomorrow, not only to the speakers, also to all the listeners and visitors, we will have a next one definitely on at the Aero at eFlight Expo. And one of the good experience in the bad Corona crisis is that we will much more implement such kind of online participation in this kind of events, because up to now, before, I had so many people who said, I would have liked to join the eFlight Expo for 10 years, but I never made it because we had sun and fun at the same time with this and that, or I would have to travel far. So with this, even if we can travel again, that it will still be limited. So you can come to these events always online. That's also why we tried to make this event here not with a very high entrance fee, because our purpose is really to distribute the know-how on electric aviation, because I think we're still in a very pre-competitive area. So as much as we can communicate know-how, the better it is for the community and for things growing, and for electric aviation can be growing. With this, I think I hope to see you tomorrow. Thank you for today, and stay healthy. Just scan the QR code on this page, or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying, eVTOLs, and everything which is connected with electric mobility in the air. Or you can click the link on the top, and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching, and goodbye.